Well, hello, fifth grade math teachers. Welcome to our first weekly preview video where we preview the content that you'll be teaching your students the week of September 19th through the 23rd. I'm so excited that you've jumped on with us to go through these TEKs and how exactly we're going to teach this to our students. And I'm hoping that the things that you learn in this video will be able to be translated into your PLC and your planning time and help you put together a great plan for how you'll deliver this instruction to your students. This is such a fun subject, and I'm so excited to be able to share the things that we've learned as a teaching and learning department with you in this video. So diving right into the week, you'll notice that it's a pretty straightforward week. Monday through Thursday, you'll focus on TEK 5.2b, which has students comparing and ordering decimals through the thousandths place and representing those comparisons using the inequality symbols or the equal sign. Then on Friday, you'll turn your attention to a supporting standard, which has students rounding decimals to the tenths or hundredths place. This readiness standard, 5.2b, has been tested 10 times in the last 5 years, while the supporting standard, 2c, has been tested 3 times in the previous 5-star tests. And so these are pretty high priority standards, especially when it comes to 2b, because of the frequency with which it shows up on the STAR test. Diving right into TEK 2b, we want students to be able to answer this STAR level question. Which comparison of these running times is not correct? One big misconception and problem that arises whenever students try to answer these questions is they are not comparing the correct place value to one another whenever they look at the numbers. And so what we would have them do is write the numbers on top of each other, 20.3 and 20.35 for the first answer choice, and then any number that is not far enough out on the decimal place, they need to add in a 0. And so the 0 will go there so that I can correctly compare these two numbers. Well, I see that in the tens place, they both have a 2. In the ones place, they both have a 0. So far, they are the same number. Keep going to the tenths place, they both have a 3. But then when I get to the hundredths place, this number has a 5, and that 5 is greater than 0. And so I know that 20.35 is going to be greater than 20.3. Or another way to say that is the way it's written in the answer choice, that 20.3 is less than 20.35. I know that that is a correct comparison, which means that it is not the correct answer. Moving on to letter B, we would have 19.795 and then 19.8. But I need to continue going and put 2 zeros, because what you'll see students do if they're not careful is say that 795 is bigger than 8. But this is not 795, it's 795 thousandths, and that is actually smaller than 800 thousandths, which is true whenever we write those 2 zeros out. It makes it very clear that this is 800 thousandths, and so therefore we know that this number right here is greater. And so 19.795 is not greater than 19.8, and so letter B is the correct answer. Letters C and D, you'll notice that the student should be able to figure it out just based on the whole number itself and not even looking at the decimal. So 20 is bigger than 19, therefore that one is correct and is not the right answer. And then here, 20 is greater than 19, which is correct, and so therefore not the right answer. Notice that they're going to have to be able to understand how an inequality comparison statement works in both directions. So they're really going to have to understand the inequality sign and how to read it in a comparison sentence. And so, for example, in this first one, you would want them to read that 20.3 is less than 20.35, and then have them do the comparison to figure out if that is actually a true statement or not. In this STAR released question, students are given 2 numbers and asked to identify which of the answer choices should be put in the box so that the numbers are in order from greatest to least. Now remember, we are moving all online for STAR, so unless you are having your students practice writing on their Chromebook screen with a screen protector in a safe and smart way, then you want to have your students practicing writing these numbers down and then putting the answer choices in the box to see if it actually makes a list that puts the numbers in order from greatest to least. So if I start by rewriting down 6.027, then I will put a line here and then 6.009. And what I know is that I want the order to be from greatest to least. So I need this number to be greater than my number in the middle, and I need my number in the middle to be greater than 6.009. If I start with the first answer choice, I've got 6.25. Well, if I look at 6.25, this number does have a 6 in the ones place, which matches this number. It has a 2 in the tenths place, and that is greater than, not less than, the number in the tenths place for 6.027. So I know that this number is not greater than this one, and so therefore that answer cannot be correct. I then go on to the second answer choice, 6.02, and I put that one in the middle and see if this one works. What I notice, however, is that this is not to enough decimal places or place values in order to be able to accurately compare. So I'm going to have to remember that I can add a 0 to the end of that number, and that does not change the value of the number. Students need to know that they can add as many zeros as they want to the end of the number, and it will still be the same number. Now I can accurately compare. If I look at the ones place, they both have a 6. If I look at the tenths place, they both have a 0. If I look at the hundredths place, they both have a 2, so far they're good. Then if I look at the thousandths place, this number has a 7, and 7 is greater than 0. So far what I notice is that this inequality sign is true. Then I go on to check the next one. And so then what I see is that both numbers have a 6, both numbers have a 0 in the tenths place, this number has a 2 in the hundredths place, and this number has a 0 in that place. And so that means that this number is greater than this number. And so that means that this inequality sign also checks out. And so therefore we have found the number that goes in the box to make those numbers go from greatest to least. This is another question where we would really want to see the students thinking through the work that they're showing on this problem. And so as a PLC, think about the ways that you can have your students show their thinking in order for you to be able to analyze that and help them with this problem. If you look here, we want the position that Juan's suitcase would be if the weights in the suitcase in pounds were ordered from greatest to least. And so that means because we want to go from greatest to least, we want to start with the largest number. Then if we start looking at the numbers, every number has a 2 in the tens place. So we move on to the ones place. Juan has a 1, Tiana has a 4, Kimberly a 1, and Emmanuel a 4. So that means for the greatest number, it's not going to be Kimberly and it's not going to be Juan. That means we need to compare Tiana and Emmanuel. We go to the next place value and we see that in the tenths place, Tiana has an 8 and Emmanuel has a 7. That means that Tiana is the largest number or the largest weight in this particular case. And so I'm going to start by writing down Tiana, and I'm going to also write down her number underneath, 24.8. And I know that that is the greatest number in that list. Then the next greatest number, of course, would be Emmanuel from the previous work that we did in our comparisons. And so 24.75 would be the next number. Again, going back to that ones place and making sure that we're eliminating Juan and Kimberly. Then if we compare Juan and Kimberly, what we're going to see is that the 2 and the 1 are good. And so then we go to the tenths place. Juan has a 6. Kimberly has a 4, and so Juan has a greater number in the tenths place value, and so therefore he is going to be the next in line. So Juan, with his number of 21.605, is going to be the next one. Then, obviously, the last one would be Kimberly. And at this point, we have enough information to answer the problem. 21.48 would be the number for Kimberly. And so what we see is that Tiana is first, Emmanuel is second, and Juan is third. And so third is going to be the correct answer in this particular case. One thing that you may want to have students do from the very beginning of the problem is go ahead and fill in the missing place values on these numbers so that they can do that comparison correctly. Because one of the big misconceptions is that they're going to see the 605 that's in the after the decimal here and think that that's greater than 8. But remember that that's not an 8. It's an 800 after the decimal place. And so filling in those missing zeros will really help your students to work through that misconception. Looking at this star released item, we want the list that does not show the numbers in order from least to greatest. And so what we're going to do for each answer choice is a strategy of writing the numbers vertically and then also taking them out to the thousands place so that we can correctly compare them. Starting with the first answer choice, we have 4.036. We have 4.08 as the second number, but we're going to go ahead and add this last zero for the thousands place so that we can compare to the thousands place. Then for 4.2, we're going to have them write out the 2 zeros so that we can again get all the way to the thousands place. And finally, 4.201. Then, because we see that in the ones place, each number has a 4, all we're going to have to do from here on out is compare how many thousandths each of these numbers has. And if it goes in order from least to greatest, then we know that is not the correct answer since we had this word not in our question. So looking at this, we have 36 one-thousandths, we have 80 one-thousandths, 200 one-thousandths, and 201 one-thousandths. And so since those numbers go in order from least to greatest in the thousandths place, we know that A is in order from least to greatest and is therefore not the correct answer. Moving on to letter B, we would start with 3.090, adding in that extra zero, 3.100, 3.607, and then 3.900. Again, what we notice is that the same number appears in the ones place, and so all we need to compare now is how many thousandths these numbers have. This has 90 one-thousandths, 100 one-thousandths, 607 one-thousandths, and 900 one-thousandths. And so therefore it is in order from least to greatest, which means it is not the answer that we're looking for in this particular problem. We move on to letter C and again use the same strategy. We have 6.400, 6.510, 6.387, and 6.995. Again, anytime we see a number that doesn't go all the way out to the thousands place, it's a very good idea to have your students write in the trailing zeros so that they can get it all the way out to the thousands place. Then what we see is that we have a 6 in the ones place for all 4 numbers, and we just need to check on the thousandths. This has 400 one-thousandths, 510, 387. Well, what I notice is that number is not bigger than 510, and so this is not in order from least to greatest. And so I have found my correct answer here. It is letter C. And you could go on and do the same strategy with letter D to show that it is not in order, or that it is in order from least to greatest. I wanted to show you one more star released question just to emphasize one thing that you're going to want to make sure that your students are fully aware of and understand really well. And that's the fact that anytime you have those hanging zeros at the end, it's equivalent to any time you don't have the hanging zeros at the end of the number. So if you look here, we want to know the statement that correctly compares two of these numbers. And if you look at letter D, which is actually the correct answer here, the students would have to know that if I add another 0 to the end of that right side number, it's going to make it the same number, and we see that this number is equal to this number. So please make sure that your students are aware that they can add zeros to the ends of all of these numbers, as many zeros as they need to in order to compare the place values. So before we wrap up talking about this TEK, I wanted to go over some of the misconceptions that you might see in your students so that you can try and make sure that they're able to avoid those. The first is comparing the number of digits in a number after the decimal place instead of applying understanding of place value. And so they might see this as 451 is greater than 98, but we know that we're not really comparing 451 to 98. We're comparing 451 thousandths to 980 thousandths. And so that means that this inequality sign would actually need to be reversed because the students have to be comparing place values. And so please be very careful that they are understanding that place value and not just comparing the number of digits. The second misconception is what we talked about in the previous problem, not understanding that 0.7 and 0.70 are actually the same decimal, and that we actually have equivalence between those two numbers. And then finally, the last misconception is you want to make sure that students are viewing comparison statements as equivalent. So for example, if I say that 5.246 is less than 5.43, that's the same thing as saying that 5.43 is greater than 5.246. And so you want to make sure that students are able to see those comparison statements both ways, not just with the bigger number on the left, but sometimes with the bigger number on the right with a less than sign, because that will come up in STAR-released questions. Before we move on to TEK 2C, I just wanted to point out a couple of resources that are available in Forethought that I think would really benefit your students. There's a great pair deck for day one where the students have to write out the number in each place value so that they're having to really go through and compare each place value one at a time. There's another pair deck where they are able to look at the model of a number and sort of use that as an understanding of how to compare and order these decimals. And then on day two, on Tuesday, there's the opportunity for your students to have an engaging time of playing Decimal War. And so with those 4 days of 2B, obviously you're not going to be teaching all 4 of those days. There will be a lot of time for student practice. And with the frequency with which this TEK shows up, we want to make sure that we're giving them practice with all the different ways that this could be tested on STAR. 2C is a very straightforward standard. It just says to round decimals to the tenths or hundredths place. So for this problem, what is 0.64 rounded to the tenths place? Well, students have been rounding numbers since 3rd grade. We're just moving it out further on the decimal place value chart. And so what we are going to do here visually is to remind students that for 0.64, if we want to round to the tenths place, then we're really going to be looking at, is that going to be 0.6 or 0.7? And we want to find the midpoint between those two numbers. Well, it's usually pretty difficult to find the midpoint between 6 and 7, but if we extend this out to the hundredths place, then that will make finding the midpoint easier. The midpoint between 60 and 70 would be 0.65. And our number is 0.64. So locating that on the number line, that's going to be about here. And because that is before the midpoint, that means that that number is going to round back to 0.60. Students have also probably been using the shortcut since 3rd grade after they discover it. And so if you want to introduce the shortcut here, that's perfectly fine as well. But we don't want students just skipping to the shortcut and not thinking through the visual aspect of this problem. And of course, that shortcut would be where if we're rounding to the tenths place, we're going to look at the digit after that. Because that number is 4 or less, we know that the number is going to round down to 0.60. Now, this particular question is interesting because this number is actually going to fall right on the midpoint whenever I do my visual of a number line. If I'm wanting to round to the nearest hundredth, then that means I am going to be looking at the hundredths place, and so we have 9.37. So this number will either round down to 9.37 or it will round up to 9.38. Again, finding the midpoint between 37 and 38 is rather difficult, so that's why we have students go out that extra place value to the thousandths place. Now, between 370 and 380, we have 375, so 9.375 will be our midpoint. And notice, again, that our number falls right on that midpoint, or exactly halfway through this number line. And so we need to remind students that anytime the number is either at the midpoint or above the midpoint, past the midpoint, then that number is going to round up to 9.380. Now the 0 here is redundant, it's unnecessary. You can remind students of that from their time going through Monday through Thursday on TEK 2B, that we don't actually need that 0, and so that's why the answer shows up as 9.38. I hope this has been helpful for you to go through these two TEKs and see some of the STAR released items and how we would have students answer them and some of the strategies that we use. Again, as a reminder, as part of the pre-planning process, you want to go through all of the released items and work through them as if you are a student and try to find those areas where students might fall into a misconception or exactly which skills you need students to know and be able to show in order to reach mastery on that TEK. If you have any questions about either of these two TEKs or any of the content from the week of September 19th, we will have office hours for you on Tuesday, September the 13th from 3:30 to 4. This will be a come and go session where you can come, ask your question, and then leave, and we would love to help you with anything that you might need for this week of content. One last thing before you go, we want you to fill out a survey that will help us to know that you watched the video, and then your feedback will help us serve you better in future videos. So use the link that's provided on this slide, or you can use your phone to access the QR code that you see there in order to fill out our survey. That way we'll have record that you watched the video, and also this will help us with your feedback. Thank you so much, and we're so excited to hear how it goes for you on this week of September the 19th as you teach your students how to compare and order decimals out to the thousandths place and then round decimals to the tenths and hundredths.